Alright, so this is the last video of this first chapter, and it's dealing with density and how it relates to different things. So you want to remember that density is an intensive property. It depends on only the composition, so what is it made up of. Density does not change based on size, so if it doesn't matter if you have a large amount of gold or a small amount of gold. If you have gold, the density will be the same. And basically, it's a measure of how much mass is in a specific volume, and the formal equation is density, if it likes me. Let's see, there we go. Density is our mass over our volume. And you can algebraically rearrange that to solve for any of the equations. There's a couple of just general things. Typically, as the temperature increases, your density does decrease slightly, not large amounts, but it does technically do that. And an important exception to this is water. So what's unusual about water is we all know that ice floats, and usually solids are the most dense state of matter for a particular kind of chemical. But in this case, liquid water has really strong intermolecular bonds, and it actually makes water more dense than ice, which is unusual. One thing you want to know about is that water has a density of exactly 1 gram per centimeter, so that's a big one you want to know. And if you know the density, you can determine if it will float or not. So if your density is less than 1, then you're going to float, which is what you hope all your boats that you ever ride in are. And if you're more than 1, then you're going to sink. So what we're going to do is just really a couple simple problems with density, and then that's it for this one. So the first thing we want to do is just the simplest density problem we can do. We want to calculate density. We're given our mass, we're given our volume, and all we have to do is just plug and chug. So our equation is density is mass over volume, and we're literally going to plug that in. So we're going to have 75.2 grams over our volume of 10.9 centimeters cubed. And I'm just going to have my handy dandy calculator, and I'm going to divide those out, and I get 6.899082 blah blah blah. You have to round it to the correct sig figs. In this case, our answer can have 3 sig figs. So with rounding, what we're going to get is 6.90, and then we have to have our units, which is grams per centimeter cubed. And then the last slide we're going to do is just a couple more problems. So number 2 is we're given a density and they're asking us to convert it, and we're just going to do one of them. We won't do both. You can try the other one on your own to make sure you can get it. But we have corn oil has a high density. It's very thick, and we're going to convert it. So let's just convert it to the first one. And what you'll see here is we have 6.89 grams on top over centimeters cubed. And we need to go to kilograms per millimeter cubed. So it's going to be a 2-step situation. So the first thing we're going to do is we're going to say that in 1 kilogram, there is 1,000 grams. That takes care of our grams to kilograms. And then what we need to do over here is just go from the centimeters cubed to millimeters cubed. So if you remember, 1 centimeter is 10 millimeters. And then because this is a 3-dimensional conversion, we need to do the whole thing cubed. And then once again, what that'll do is it'll make it 3-dimensional. Our centimeters cubed will, cancel, and we can do this. So we have 6.89 divided by 1,000 times 1 cubed, which is just 1, and then divided by 10 cubed again, or by 10 cubed, I should say. Oops. And I got 6.89 times 10 to the negative 6 kilograms per millimeter cubed. And that's really just a conversion factor, but a conversion factor that relates to density. The third one deals with density. We have a 68-gram bar of gold. We cut it into 3 pieces, and we want to know how does the density of each piece compare to the density of the original gold bar. So take a second, try and think about it. Pick one. And the answer is formally C. It does not change. Density is not dependent on amount. It is dependent on composition only. So it doesn't matter. Each of those densities, they would have a smaller amount of mass, but it would be in a smaller amount of volume. So the density would not change. And last but not least, our number 4 is we want to calculate volume given mass and density. So if you remember, density is mass over volume, and we're looking to solve for volume. So we're going to have to algebraically rearrange this. So the first thing I'm going to do is multiply both sides by volume. And what that gets me is volume times density equals mass. And then we want to get volume alone, so we're going to divide both sides by density. So the equation we're working with here is volume is mass over density. They give us our mass, they give us our density, so it's just a plug and chug from here. The algebraic rearrangement, though, is expected. Like, you should be able to do that. So our mass is 14 grams. Our density is 10.5 grams per centimeter cubed. Now, you want to check your units, and our units work here because our grams are going to cancel. And then we'll have 1 over centimeters cubed, which is just centimeters cubed mathematically, and that is a volume, so that actually makes sense. But if we do our math quickly, our answer is 1.3 repeating, so with sig figs, it's 1.3 centimeters cubed. And that is it for this first chapter. I hope you made it through, hope you like chemistry, and we got to start working on the review for the test. Oops. There we go.